Hi, welcome to this lesson on number patterns, sigma notations. Let's have a look at question 4 on solving a sigma notation problem. In this question, they want us to determine the value of this following series. The sum from k equals 1 to 50 of 5k plus 2. So that is your general term tk, 5k plus 2. Now, if we had to expand that, look how long this would be. It would be 5 times 1 plus 2 plus 5 times 1 plus 2. No, 5 times 2 plus 2 times plus 5 times 3 plus 2 plus all the way up to the last term, which is the 50th term, 5 times 50 plus 2. So there are 50 terms that we are adding up here. So to expand that out and do it through normal manual arithmetic can take us quite a bit of time. So let's use the properties of sigma notation to help us. First of all, I'm going to break that up into two sums. The sum from k equals 1 to 50 of 5k plus the sum from k equals 1 to 50 of 2. Now I'm going to use the constant law here and bring out the 5. So it'll be 5 times the sum of k equals 1 to 50 of just k plus the sum from k equals 1 to 50 of 2. So let's break it down first. This second term here is the summing constants formula, because you're summing the constant number 2 how many times? 50 times. So we know that that is going to be 2 times 50, which is 100. So this entire expression here is just equal to 100. In this case, if I look at the summation k equals 1 to 50 of k, well, we know from the summation formula 2 on your formula sheet, this one here, the sum from I equals 1 to n of I is just n times n plus 1 over 2. That's why this is a pretty nice formula to know. That's why they give it to you in a formula sheet, is because it can save time when you're doing these type of summation problems, where generally you can actually extract that information from the question. So instead of I, you're just starting at k. So yeah, it's k equals 1 up to n, which is 50, of instead of I, it's now k. So the upper bound here is 50, so it's going to be 5 times 50 times 50 plus 1 all over 2. Okay, and then you're adding 100. So let's see, 50 divided by 2 is 25. 5 times 25 is 125 times 51 plus 100. Okay. I'm going to use the calculator for this one just because the numbers are not that nice to deal with. So 125 times 51 is 6375 plus 100, which gives me a grand total of 6,475. How can we check that that is correct? Well, if I open the calculator and I do summation of 5x plus 2, and I start at 1 and I go to 50, what does that give us? 6,475. Exactly the value that we derived. Okay, so instead of trying to do that long summation manually, I just made use of the properties of sigma notation and then used that second summation formula on the formula sheet. You'll see that those formulae actually pop up more than you think if you look carefully enough in the summation notation problems. Okay, I'll see you in the next one.